Hello and welcome to my YouTube channel. Today we are going to see how to program UART module in the TIVA C board and briefly talk about the features of a UART. So first of all, the question comes to the mind is what is UART? UART is basically Universal Asynchronous Receiver Transmitter module, which is used for communication between the microcontroller board with external peripherals or external devices. Remember, this is asynchronous, so therefore it is not dependent on the clocks of the microcontroller. Rather, we have to specify our own speed or our own clock rates for the communication. This module can do receiver and transmitter functions both. So first of all, the microcontroller TM4C123GH6PM, which is present in the TIVA C board, generally have 8 UART modules. So we can communicate with 8 different peripherals using UART modules present in the TIVA C board. These modules can be configured at a baud rate of 5 megabits per second or 10 megabits per second for high speed communication. For that, we just have to change the modules time division by 16 or time division by 8 respectively. So remember, we can choose two different speed rates or baud rates. One is 5 Mbps and second is 10 Mbps. Apart from that, the UART module present in the TIVA C board or TM4C123GH6PM microcontroller has got 16 cross 8 transmitter and receiver FIFOs. FIFOs are basically first in first out registers which act as buffers and stores the data in them. Okay, so you have 16 registers and each register can store 8 bits during transmission and reception. This actually reduces the load on the CPU when it is handling interrupt service routines. These FIFOs can generate interrupts or they can trigger the interrupts when they are filled by 1 by 8, 1 by 4, 1 by 2, 3 by 4 or 7 by 8. It means when the FIFO is filled by 1 by 8th of its total memory size or 1 by 4th by its total memory size or 1 by 2 and so on. Apart from that, for communication, we have certain bits to be kept in mind like the start bits, the stop bits and the parity bit for asynchronous communication. Now the UART module in the TIVA C or TM4C123GH6PM microcontroller can support word length of 5 bits, 6 bits, 7 bits or 8 bits. So these are the word size which you can choose during the programming of UART. Similarly, we can have even, odd or no parity bit generation or detection that again can be configured during the UART programming. And we can also configure 1 bit or 2 bit stop bits during the generation. That means we can configure 1 stop bit or 2 stop bit if we are programming UART communication. So basically how the UART communication connection is made. For UART communication, if suppose we have two modules which support UART communication, then in that case the transmitter of one UART should be connected to the receiver of the second UART, and similarly receiver of the first UART should be connected to the transmitter of the second UART. So this is kind of cross connection between transmitter and receivers. This connection has to be kept in mind when making the physical connections between the UART modules. Now, how to set up UART module in the TIVA C board? So we have to follow certain steps to follow the to configure the modules. First thing is to provide the clock to the UART module. Like I said, there are 8 UART modules. You can refer to table number 14.1 of the datasheet for TM4C123GH6PM. You can download the datasheet and refer to table 14.1, and you can see the different pins which are assigned for UART communication. So UART 0 transmitter and receiver, you can see pin number 17 and 18. So UART 0's receiver is pin number 17, UART 0's transmitter is pin number 18. Receiver is connected to PA0, that is port A's 0th pin, and transmitter pin is connected to PA1, that is port A's first pin. This thing we have to keep in mind while programming the UART. Now, in our code, we are going to use UART 0. You can modify the UART according to your choice. Only thing you have to keep in mind is the pin number of the microcontroller and the port which actually is connected to the UART modules, transmitter and receiver. Second, we have to provide clock to the GPIO port A. Because we are using port UART 0, we have to configure port A because port A's pin are connected to UART, transmitter and receiver. Third, we have to configure the pins in the GPIO as transmitter and receiver. Then we have to configure the baud rate. Baud rate means the rate at which the message is transferred between two devices. Then word length. It can be 5, 6, 7 or 8 bit. Number of stop bits and parity bits. So this we have to configure before starting the UART communication. Then to verify the communication, what we can do is we can download a software called TerraTerm, which will be used to check the messages transmitted by the board in the console of TerraTerm software. Let us now code the program using Code Composer Studio, compile it, upload the code in the TIVA C board and see the message in TerraTerm software. For that, let me open the Code Composer Studio. So it will take maybe 1 or 2 seconds to start the Code Composer Studio. Now, as usual, we will start a new project. For that, we can click on New Project, or we can go to File, New, CCS Project. In these two ways, we can start a new project. Let us start the project. For that, click on New Project. And now, we have to select the microcontroller TM4C123GH6PM. Select the microcontroller. Select the connection between your PC and the microcontroller board. For that, we can use Stellaris in-circuit debug interface, or also known as Stellaris ICDI. Select that. Give a name to the project. So let me give the name UART Communication TIVA C. And then select empty project with main and click finish. Now a simple program or a basic program will be uploaded. Apart from that, in the left Project Explorer window, we can see all the files which are already created by the CCS or Code Composer Studio. So right click on the project, go to properties, go to include and click on add, go to browse. Because we are going to add the Tivaware, go to Tivaware C series 2.2.0.295. If you have not downloaded Tivaware, I have shown how to download and install Tivaware in the first video of this playlist. So select the folder, click OK and apply and close. Now we have to also add the driver lib. So add files, go to C folder. If you have downloaded and installed the Tivaware, open the TI folder. Inside that Tivaware C series 2.2.0.295 folder, and inside that open the driver lib folder. Because we are using Code Composer Studio, open the CCS folder. Inside the debug folder, use driverlib.lib folder and file and open it. So you will get two options. Either you can copy the files or link two files. I prefer to copy the file so that this file will be available in my project folder. Click OK. Now we can see the driver lib file has been added. And as usual, we will have to add some header files for proper functioning or proper usage of the features provided by the driver library files. So let me first include standard integer std int.h, then include standard bool.h, then include, for auto completion we can use control space, and now we have to use inc hardware memory map, then hash include. These things we have been doing in almost all the projects, so I now believe most of you might be aware of the importance of these files. Okay, so home, let me delete hash. Okay, and then hardware types, hardware underscore types dot h, hash include driver lib slash sysctl, because we want to provide clock to the peripherals to activate them. So sysctl is the, or system control.h is the file which contains all the relevant functions or for activating the peripherals. Then we can include hash include driver lib and gpioh dot, because we are going to use gpio. For that we have to use gpio functions, and then we can use hash include driver lib kinmap.h, and then last header file will be driver lib UART.h, because we are going to use UART in this program. So remember, we are using UART. For that we have used UART.h file. We are using GPIO, therefore we are using GPIO.h, and sysctl provides or activates the peripherals. Here in our case, GPIO and UART are the peripherals which we are going to use. So sysctl.h will be providing the clocks or activating these two peripherals. Now, before writing the main code, let me define some variables which will be used to work with the UART module. So let me call the UART underscore module, because we are going to use UART 0. Okay, so we'll be using UART underscore base. Okay, and now we have to use hash define. So UART underscore GPIO underscore port, and we know that GPIO port which we are going to use is GPIO underscore. Okay, let me just compile the program so that I will be able to use the autofill functionalities. So let me compile it now. Okay, let me check if I get the autofill facility. Define UART underscore GPIO underscore port. For that we have GPIO underscore port. We know we are going to use GPIO port A because we are using UART 0, and UART 0's transmitter and receiver pins are controlled by port A. Now we have to use define UART underscore GPIO underscore TX. This line will be used for the transmission. So let me declare GPIO underscore pin 1, because port A is pin 1 and pin 0 will be used for transmitter and receiver. So hash define, I'll just copy this part, Control C, Control V. Instead of TX, I will use RX, and instead of pin number 1, I'll be using pin number 0. Why? Let me again go to the data sheet and show you that receiver of UART 0 is connected to port A's 0th pin. Transmitter of UART 0 is connected to PA1. So that's why we are using these two pins in the port A. So pin 0 and pin 1. Okay, now, or if you needed, we can add some comments. So pin A is UART 0's TX pin. Okay, and this one is UART 0 RX pin, which are connected to port A. Okay, this is port A pin 1, and similarly we can just put a comment for this one 0. Okay, so we have defined 4 variables. First one is the module which we are going to use, that is UART 0 module. The port A we are using because UART 0 is actually connected to port A, and then we have defined the pin for transmitter and pin for receiver. Then last we have to define the baud rate. The baud rate will define the speed by which the communication will take place. So BAUD baud underscore rate, and for that I can choose 1515200. This will be the baud rate of our communication between the microcontroller board and the PC. Now let me go to the main and first set up the clock for microcontroller. For that we have to use sysdict, and let me just add the C files of the GPIO, SysTick and UART so that we can avail the features of all these three peripherals. So GPIO, coming down, we have sysctl and then UART. So I'm going to add these three C files, copy to the project folder. So we have now gpio.c, sysctl.c and uart.c. Now let me open the sysctl first so that I can configure the clock. Remember, you should always prefer to view the outline window. So for that you can go to view and click on the outline window, and in the outline window you can see all the functions which are available with the corresponding C file. So to set the clock frequency, we have to use sysctl clock set function. So let me just check sysctl clock set function, and here we can see what this function will do. It sets the clocking of the device, and it needs certain arguments like the clock frequency, whether you are going to use the main oscillator or you are going to use PLL and so on. Okay, so let me first copy the function and then populate the function with corresponding arguments. So we paste the function in the main program and then delete this argument and let us populate the argument. So sysctl underscore sysctl underscore, okay, let me just populate it. Sysctl underscore sysdiv, and let me divide it by 4. So sysdiv underscore 4. Okay, so sysdiv underscore 4 we can choose, or sysctl underscore use oscillator, then again an or, sysctl underscore oscillator main, then or sysctl underscore crystal 16 megahertz. Okay, so all these features I have used using autofill facility. Otherwise, what you can do, you can go to the sysctl.c file. Inside that you can check this function and read about this, what are the arguments we can use, such as crystal 16 megahertz, okay, sysctl oscillator main, whether you want to use the PLL or not, and so on. So we have configured the clock for the microcontroller, and now we have to enable the UART functionalities or initialize the UART functionalities. So just click on the UART.c to access all the features available in the UART function or UART.c file. So to initialize the UART, we just have to use UART init function. So UART underscore, sorry, not underscore, UART init, UART. Okay, here let me check UART init function. So for that, let me just declare a function to initialize the UART module. Okay, so to initialize the UART module, let me declare UART init function. This is our own function which is not provided by the UART.c. And let us go to the, well, let us create a function for that and declare the function. So this is our function. So let us just copy this and void UART init, and it will return nothing. So therefore we will be keeping it void curly braces. So let us now populate the UART init function. First thing that we have to do is to provide the clock to the UART module and then clock to the GPIO port A. For that, to provide the clock, we have to use sysctl.c file. So because we have to provide clock to the peripheral, we have to check which function is going to help us. So sysctl peripheral enable. So this function we will be using, and let us see what are the arguments here. So this enables a peripheral because UART and GPIO both are peripherals. This function will be used, and these are the list of functions, the list of peripherals which we can enable using this function. Let me first copy this function and paste it inside my UART init function. And for the argument, I will just delete this argument, and because we are going to use GPIO A, we can just copy this argument sysctl peripheral GPIO A, copy this and paste it here. Okay, and to provide clock to the UART, similarly copy this function. Instead of using GPIO A as an argument, what we can do is we can copy the argument for UART 0. So this is the argument sysctl peripheral UART 0. Copy that and paste it here. So we have activated, or we can say enabled, the UART 0 module, and this one has enabled the GPIO A module. Now after that we have to configure the GPIO pins for UART function. So configure the GPIO pins for UART function. So first of all, to configure the pin as UART in the GPIO, so open the gpio.c file. Inside that, let us use GPIO pin configure function. GPIO pin, come down and let us check GPIO pin configure. Here we have the GPIO pin configure function. What it does, it configures the alternate functions of a GPIO pin. What does that mean? In general, the GPIO pins can be used for digital purpose, that is making them on or off. Instead of that, if you want to use any alternate function like ADC, PWM, timer, or UART, then in that case we have to configure them using alternate functions. Okay, so for that we have to use this function GPIO config function. Copy and paste that. And what is the argument for this function? That is important. So we can just go to GPIO C, and argument will be the functionalities that we want to use on them. Okay, so for that we have to use GPIO underscore PA pin A, and we are going to use pin A's receiver. Okay, so RX, and then similarly GPIO pin configure function, and for that we have to use GPIO underscore PA1 as UART 0 TX. So we have configured PA0 as UART 0 receiver pin, and similarly, let me copy this, Control C, semicolon, paste. UART PA1 will be acting as UART pin transmitter pin. Okay, so we have configured the UARTs transmitter and receiver pin. Now we have to use another function from GPIO because we are using UART. So we have to you have to tell the system that you are going to use GPIO pin for UART functionality. For that we will use GPIO pin type UART, copy this function and paste it, semicolon. Now here we have to provide the port and pins details. So for the port, we know this is port A, so UART underscore GPIO port, okay, because we are using GPIOs as port. And now to configure the pins, we have to use UART underscore GPIO port receiver and transmitter. Okay, this, or let me just copy this and paste it again. Control C, Control V, TX, and okay. So we have configured the GPIO pins for UART functionalities. Now let us configure the UART. So configure the UART. Now remember, in UART we have to provide the details related to the baud rate, the word length, stop and start bits, and parity bits. For that we have declared here the parameters for the UART. Okay, this is our baud rate and which module we are using and where is the port for that. Let us configure the UART. So to configure the UART, again open the UART.c file. Inside that we have to use UART config set exp clock. So what does that mean? You come up and see sets the configuration of UART. We have to provide 4 parameters. So first parameter is the base address of the UART port. Second is the clock, which will provide the clock to the UART port, the baud rate, and then the format with data bits, stop bit, and parity bit. So these 4 arguments we have to fill. So first copy the function and paste it in the project. Now, first of all, the base address of the port, and we know the port module is UART. We have defined it, UART module. Okay, and UART module, we know UART module is UART 0 base, or you can directly write UART 0 base also. For that you can just check what are the arguments allowed for that. Okay, for that you can just check the function. Now second is the clock. Okay, so for that we can use an inbuilt function in the sysctl.c to provide the clock. So sysctl clock get function we can use. Sysctl clock get function we will be using. So let me just check sysctl clock set and clock get. So this function gets the clock of the processor. So we will be using the same clock which is available in the processor to specify the clock for the UART port. Now we have to specify the baud rate. So here we have specified the baud rate as 115200. So we will use this variable. So baud baud underscore baud rate. And now to configure the last argument, we have to provide 4 details. For example, here you can see in the last argument config, you have to configure the data bits, then stop bits and parity bits. Data bits means the word length. So here first we have to provide the, let me start a new bracket, UART underscore config the word length, config the word length, w length as 8. That means each word will be of 8 bit. You can choose between 5, 6, 7 or 8. So we are using 8 bits for the word length. Or now specify the stop bit. So UART underscore config we have to specify the stop. So config then stop 1 bit or 2 bit for stop. So if you are using a normal speed, then you can go for 1 bit. If you are going for very fast communication, you should go for 2 stop bits for error free communication. So in this we are using not a very high speed communication, so we can use 1 stop bit. And or then we have to use UART underscore config. Last we have to use the parity. So you can use even parity, you can use no parity, odd parity, 1 or 0. So I will be using no parity. So I will be using use config parity none. And that completes our UART configuration. And now let us, okay, let me delete the rest of the space. Okay. Now, after this, we have to print a message. So for that, in the main, we have initialized the UART. Now to print a message, we can use while function, while 1. That means it will continue for infinite number of times. So while 1, we are going to print a message. So for that, let me declare a function print message in the UART. And now let me use another function from UART.c to print the message. So for that we can use UART print function. So UART print function. Okay, so let me declare a new function UART print function. And this is our own function, so it is not provided in the UART.c file. And we are going to print hello TIVA C code. Okay, this message we are going to print, and for the carriage return \r next line \n. I will show the difference between these messages with and without slash and r when we will be using the Terra term. Okay, now after this print will continue. This message will be printed in the Terra term or the serial monitors console continuously. For that, to make a small delay between that, we can use a function from the sysctl, okay, to generate a small delay. So we can use sysctl delay function here, okay, to generate a delay between two prints. So I will using sysctl delay, okay, this function, and we have to provide a count in the delay function. So based on this count, if the count is very small, the printing will be very rapidly printed, or the message will be printed very rapidly. If this delay is long, then the message will be printed after a long delay. Okay, so to control the delay, you can just increase or decrease the count in this function. Now let us create a new function for the UART print. So we have this, and let me create a new UART print function. So void UART print function, okay, and you can use constant because we are using characters to print. And remember, C do not support string or data type, so we'll be using character, and we'll be using a variable to hold the message. So for that, we have declared a function void UART print, and we are going to use this argument, that is character star message. Star message means the pointer to the address of the message. Now while the message is not equal to 0, or it reaches to the end of the message, for that we can use this function /0. Okay, so till the message is not completed, we have to use UART char put function, which is available in the UART.c file. And where is this message generated? From the UART module. So the message will be generated from UART module, which is UART 0. And what is the message? The message will be till the end of this message, okay, variable message. Now let me just put a semicolon here. Done. And okay, this is all about the coding part. So let me just check if the program has been written in without any error. So for that, let us compile the project and check if there is any error. So there are 5 warnings. Okay, some data, okay, this is not reachable, and we are getting some errors related to the functions. So let me just copy these functions and make a prototype so that the error will be moved off. So this is another function which we have declared. So for creating a prototype, just put a semicolon in the end of the function. So another, this is init, initialization, UART init we have made. Okay, let me just compile it again. Okay, UART print has not been. So UART print, this function we have not provided the prototype. So copy this function, and this, let me check if the error goes. Okay, and only error is that return 0 is not reachable. You can comment it or keep it there. It is not a big issue, because we know while one function is there, so we will never reach to this line. So you can even comment that. Okay, and recompile and check if there is any error. So we can see there is no error in the program. So let me just flash this code in the microcontroller. For that, we can use flash And after flashing, the microcontroller will use the UART module to send the message to PC. And to read the message, we have to use any serial communication module based software. For that, I am using Term. Open that, click on the serial and see the options. Here you can see the Stellaris virtual serial port at COM port 5. So I will select this. You may have another COM port, but you will find this Stellaris virtual serial port. Select that, click OK. Still you can see the message is not coming. So go to setup, set up the serial port, and here you can see COM port 5 speed is 9600. So click on that, because we have configured our baud rate at 115200. These are the list of baud rates which are allowed in the UART. You cannot change or you cannot use any other value which is not listed here. So please make note of that. So you have to use the baud rate which is listed here. You can see the baud rate is 115200. So the same baud rate we have to provide. Data length we have selected 8-bit. Here it can have 6, 7 or 8. Parity none. If you have, because we have not used any parity, therefore we have used no parity. One stop bit and done. So this is our setup. And here we can see the message is coming, but it is coming in a very vague way. So let me just check what is the error here. Terminal. Okay, let me check again. Serial port, COM port 5. Okay, new setting. We are getting a scrambled message here. Let me re-upload this code and see if there is any error, because the message is getting printed in a very vague way. So let me just check if there is any error in the code, and for that let me just pause the video. So there was a mistake in the code, especially in the UART print function. So in the while we have not started and closed the curly braces. So we had written char put, but we have not incremented the message by ++. So we have to just add the curly braces start and end and increment the message. So let me just compile the program. Now load the program to the flash. By that time, let me open the Term software. Click on serial. Now the program has been loaded in the microcontroller. Select the COM port which is connected to Stellaris virtual serial port. Click OK. And you can see I can just clear the screen. I can just set up serial. Baud rate is 115200, new settings, and you can see here the message is coming on the console of the Term. In this way we can program the UART in TIVA C board. With this I would like to end the video because I have taken too much time in this video. If you have not subscribed the channel, then please subscribe the channel and please click the bell icon so that you can be notified whenever I upload a new video. If you have any doubts or suggestions, please use the comment section to upload your doubts or comments. Thank you for watching this video and have a nice day.